All right, let's take a look at representing functions using words and equations. This is something we've kind of touched upon as we've gone through the unit, but it's something we're going to practice again today. And if you go to page 36 in the Unit 7 packet, that's where we're going to start. So at the top it says, words and equations can be used to describe functions, which again are connections or relationships between numbers. For example, when a rate is expressed in words, it can be written as an equation with variables. When you write an equation, determine what variables to use to represent different quantities. That just means write a let statement. Now today, we might not just write one let statement, we might have to write two, depending on the situation. So for example, this first one's already done for us. Let's take a look at it. It says a runner's distance in a marathon, which is a really long race, is equal to 8 miles per hour times the number of hours. Okay? So I actually see some math words in here, like is equal to, so that's the equal sign, 8 miles per hour times the number of hours, which you don't know, which might be like, number of hours might be like the time, t. So the runner's distance is equal to 8 miles per hour times the number of hours. So the runner's distance might be d. Okay, so I mean, that one's written in a certain way. It's very clear, like what the equation might look like just based on the words that they're using. Not all of these situations we're going to look at are set up like this, but I just wanted to point out that there are just certain words and numbers, in here that might help us determine the equation. So the variables, you can see here we had to write two variables. D is the distance, and that's actually like the total. And we've talked about before how the total is going to go by itself. And you can see here in the equation, d is by itself. 8 times t is going to find you the total distance. T equals time in hours. Because we don't know how much time this runner took, and then we also don't know the distance. So the equation would look like this. D equals 8 times t, where d is the distance, total distance. Again, that's the total by itself. 8 times t is going to be what you could do to find the distance. 8 miles per hour times how much time. So again, that one's already done for us. So let's try the first one here. The drama club is holding a bake sale. They are charging $5 for each pie they sell. Write an equation to find the total amount earned, t, for selling p pies. Now what's nice about this is that it tells us what each variable is going to be. We have a variable t, we have a variable p. The words to describe this is the total equals 5 times the number of pies sold. That might help us think about our equation. So t, let's let t equal total amount earned. That's what t equals. So that's what I'm going to write down. So they're holding the bake sale. T will represent the total amount earned. P is going to be the number of pies. Now, when writing the equation, I would always start with the total, just because we know the total is going to go by itself. So T by itself equals, well, they're selling each pie for $5. So to find the total, you could take the number of pies and multiply it by 5, because each pie is $5. So let's say they sold 2 pies. 2 times 5 would be 10. Their total would be $10. So depending on how many pies they sold, that will change the total. If they sold 0 pies, 0 times 5 is 0. So there you go. All right, so I'm just going to label that again. This is the total, so the total is going to go by itself. Let's try another. You can see here we're going to have 2 let statements. In a science report, Mia finds that the average adult breathes 14 times each minute when not active. Write an equation to find the total breaths B a non-active person takes in M minutes. So you can see here, total breaths B, M stands for minutes. So what's nice is the problem almost gives us what the equation is going to look like, what the let statements are going to be. So we're going to let B equal total breaths. It's nice to have that total in there. We know the total goes by itself. And then M is going to be kind of like the input. This is the number of minutes. Number of minutes. All right, let's write the equation. So we know the total is by itself. To find the total number of breaths, this is the total. Let's see, 14 times each minute. That tells me it's probably going to be multiplication because the word each, so 14 times per minute or each minute when not active. So if an adult breathes for M minutes, to find how many total breaths, you would multiply the number of minutes by 14. So if they breathed for 3 minutes, we would do 3 times 14, and that would give us the total. 3 times 14 would be 42. So I'm just kind of using numbers to practice to see what it would look like, and just to see if the equation actually would make sense if we had a certain number of minutes to work with. All right, now, these ones below, we'll try maybe one together, and you can try the other two on your own if you want. We'll see how they go. It says, a mouse can travel 8 miles per hour. That's not bad. It's the same as the runner above. Write an equation to find the total distance d a mouse can travel in 8 hours. So those are two variables. Let's write our let statements. So we're going to let d equal total distance. Okay, and we're going to let h equal number of hours. Number of hours. Okay. All right. So total distance would be d. That's going to go by itself, of course. That's the total. I'm just putting that label there just so, again, to emphasize that the total is by itself. That's what we're trying to find. And to find the total distance, you would take 8, which is the number of miles per hour, and you would multiply it by the number of hours. So it'd be 8 or times h or h times 8. Either one would work because of the commutative property. So there's our equation, where h is the number of hours times 8 will give you the total distance. If you want to try this next one on your own, that would be great. You can try it with me as well. Samantha can make 36 cookies each hour. That word each, again, like that word each kind of indicates to me that this is probably going to be multiplication or division, I guess, but probably multiplication. Write an equation to find the total number of cookies, C, that she can make in 8 hours. Again, they're giving us some clues here using the word total. Let h equal total number of cookies. Oh, I forgot to write the letter. Let C equal total number of cookies. And we're going to let h, just like the last one, equal number of hours. So again, C, total number of cookies, that's the output. That's what she's making at the end of the day. She's not making hours, she's making cookies. So the cookies is the total. That's what she's making or producing every hour. So C is going to be by itself because C is the total. Now, it won't always say like total. So even if it said just like number of cookies that she can make in 8 hours, the cookies is what she's making. That's the output. That's what she's making. So that's going to be by itself. Now, she can make 36 per hour or each hour. So we can take the number of hours, which would be h, and multiply it by 36. So if she had 2 hours to bake, 2 times 36 would give us 72 total cookies. Can't wait to try those cookies. All right. Number 5. This one's a little different. And again, you can go ahead and try this one on your own if you want, or you can do it with me. In a video game, each player earns 5 points for reaching the next level and 15 points for each coin collected. Write an equation to find P, the total points for collecting C coins after reaching the next level. Okay, so first with our let statements, let's think about this. Let's let P equal total points. So it looks like there's two ways to earn points. You can earn points by reaching the next level or by collecting coins. All right, so let's let C equal number of coins. Okay, so the total, we know the total is going to go by itself. So the total number of points, which is P, is going to be by itself. That's what we're trying to find. It's the total number of points. And how are we going to find the total number of points? Well, again, there's two ways to get points. 5 points for reaching the next level, 15 points for each coin. Now, that 15 stands out to me first because C is the number of coins. 15 is how many points for each coin. So to find how many points this person would get for coins, we might do something like C times 15 or 15 times C. That would give us the total points for the coins. However, you also get 5 points for reaching the next level. Now, you wouldn't get 5 points for every coin you get. You just get that 5 points once at the end of the level. So because you're not like multiplying that by anything, you would just add that on to the end as like a kind of like a bonus, like an extra. But it doesn't matter how many coins you get. Like if you got 0 points, you'd still get, if you got 0 coins, you'd still get 5 points for reaching the end of the level. So 0 times 15 is 0 plus 5 would give you 5 points. So that's a two-step equation because there's two ways of getting points. All right, so what we're going to do now is sort of combine what we just did with function tables and graphs. Okay, so in this first one, we're actually going to go backwards, and we're going to use a table and a graph to help us write an equation. So when I look at this graph, when I look at this table, just like I normally would, I want to first pick out my let statements. What are the numbers we're working with that might change, that we don't know for sure? And it looks like number of hours, remember, this is the x-axis, and the x-axis is for the input. This is the y-axis for the output. So the input, or the x value, will be number of hours. So let's let, I don't know, h equal number of hours. And then the other variable is going to be the distance. That's the output variable. We'll call that, I don't know, m equal distance. Distance traveled, maybe. Okay, so I'm not sure who's traveling here or what method they're using, but I got to think about, like, what's the total here? Is the total, is what's being measured here the number of hours or the distance? Now, one way you can tell is that the output is usually the total. So the distance is going to be the total there. So the distance is going to go by itself. So we're going to let h is not the total, it'd be the miles traveled. Distance traveled in miles. Just want to be specific there. Sorry, I hope you can see that. All right, so our equation is going to look something like this. We're going to have m, which is the total, equal. Let's look for the rule here. What's going on here? It looks like every hour this person can travel, or this thing can travel 8 miles. Every hour they go 8 miles. After 0 hours, 0 miles, which makes sense. 1 hour, 8 miles. 2 hours, 16 miles. 3 hours would be 24. So each hour they're going 8 miles. So that would mean to get the number of miles they traveled, you would take the number of hours they traveled and you multiply it by 8, because the rule is, well, whatever the input is, you're going to multiply it by 8 to get the output, which is, again, that's the total. So again, we've practiced something like this before when we, I believe the last remote assignment, we were looking at how to go from a graph to an equation. So that's just another practice with that. All right, we're going to try a couple more where we're going to write an equation, do a table, and then make a little graph. The student council is holding a car wash to raise money. They are charging $7 for each car they wash. Write an equation to make a function table to show the relationship between the number of cars washed, C, and the total amount earned, T. So we have to do like three things here. We're going to make an equation, function table, and a graph. Okay, so the first we'll start with our let statements. So we're going to let t, and they're kind of like already written here in the table as well. So we're going to let t equal, I'm going to write that as a cursive t, total money earned. Okay, they're using dollars, American dollars. And we're going to let C, which is the input, be number of cars washed. Okay, so first we'll make the equation. It says they're charging $7 per car. And that's the only way they're making money, is to charge $7 for each car they wash. So the equation might look something like this. T is the total. And then what would we multiply C by? C is the number of cars. How much does it cost per car? It would be $7. $7. So if it was like they wash 2 cars, 2 times 7, they'd make $14. 4 cars, 4 times 7 would be 28. I kind of just spoiled some of this table for you, sorry. Okay, so the rule is whatever C is, you're going to multiply C times 7, and you're going to get T. So 1 times 7 is 7. 2 times 7 is 14. 3 times 7 is 21. 4 times 7, if you wash 4 cars, $28. All right, let's make a little graph. Let's make a little graph here. So there's no part of this in the table, but I'm going to actually make, and we did this before, little ordered pairs here with X and Y, or with the input and the output. So the first ordered pair would be 1, 7, 1, 7, and then 2, 14, and these will help me put points on the graph. Then 3, 21, then 4, 28. All right, so these will help me make the graph. Let's make this graph here. So 0, 0, there's already a point there. You wash 0 cars, you make $0. That makes sense. 1 car is going to be $7. So I'm going to go from 1 car, I'm going to go to $7, which is slightly closer to 5. And then 2 cars, $14. 2 cars going up to 14, right before 15. Again, this should make a diagonal line, a straight diagonal line. 3 going up to 21. It's called a linear function, of course, because it's going up by 7 each time. Going up by 7. 4 is going to be 28. Now I have a ruler handy here, so I'm going to make a little diagonal line. Nice. Whoop. I'm going to put a little arrowhead. It went all the way off the charts, but there it is. So that means 5 cars, $35. That makes sense because 5 times 7 is 35. All right, let's try one more here. It's the last one. About Maurice. Maurice receives $3 per week for allowance and earns an additional $1.50 for each chore he completes. It seems like there's 2 ways for him to earn money. Write an equation to find T, the total amount earned for X chores in 1 week. Then make a function table and a graph. So we have to make 3 things again: equation, function table, graph. Let's start with our let statements, though. And again, there's like 3 different ways you can see the let statements. They're kind of written here in the table, they're written here in the graph, and they're also in the problem. So let's let T equal total amount earned. T equal, I'm going to do a cursive T. Total amount earned. Okay. X, let X equal number of, looks like it's number of chores, which is, again, it says it here on the little function table. Let C equal a number of chores. All right, let's write this equation then. So T is going to be by itself, of course. It's the total. That's what we're looking for. All right. This person gets $3 per week for allowance, earns an additional $1.50 for each chore. Each chore, $1.50. So this is the number of chores. So to find out how much he earns for all the chores, we would have to do C, which is the number of chores, times, I'm going to use parentheses actually, $1.50, because it's a decimal. I don't want to confuse the dot and the decimal. But that's not all. He also earns $3 per week, no matter what. So we're just going to add that on to the end there. So it doesn't matter how many chores he does per week. When the week ends, he's getting $3. Nice job, Maurice. All right, so we're just going to make a little quick graph here. We're going to use our equation. So for number of chores, again, we can put any numbers in here. We might as well put the three easiest numbers, 0, 1, and 2. Okay, let's see how much he makes after doing 0 chores. 0 times 150, well, that's 0, plus 3. So even if he does 0 chores, he still gets that $3. 1 times 150, so he does 1 chore. 1 times 150 is 150. Plus $3 is $4.50. So it's going to go up by $1.50 for each chore he does. So if he does another chore, 2 times 150 is $3. Plus 3 is $6. All right, let's make a little graph here. So our first ordered pair, I guess I can write it above, is 0, 3. And then, again, the input always goes first, or the x value, and then 2, 6. So these are our 3 points. Those are our ordered pairs there. All right, let's try this out. So 0 chores. Again, we're not going to put a point here because he gets $3 for doing 0 chores. All right. 1 chore, he gets $4.50, which is exactly between 4 and 5. So here's 4, here's 5. $4.50 is going to go right between them. And then 2 chores will get us up to $6. 2 chores, $6. And again, linear function, we are going to see a straight diagonal line here. Right? There it is. There it is. Okay, well, had some good equation practice today, good function practice, and have a great day. If you have any questions, let me know. If not, I will see you soon. Bye-bye.